Now let's again click on static motor starting icon. After running the static motor starting, the alert view window pops up which tells us which devices are in the critical or marginal mode, which in this case we'll see bus 2 is running under marginal condition. Soon we will see what are the limits to have a marginal or conditional devices. Now we have motor starting time slider, which helps us understand the condition of the system in each moment of the time. Simply drag the slider and slide it to the right, and as you can see, when we pass the first second, which was the time of occurrence of the first event, right on the first second, the first motor, which is a 100 horsepower motor, would be connected in line, and the bus upstream is marginal. And you can see the power flow. We have 700 amps being driven by this load, motor 1, at the first moment that it is connected in line. This is called an inrush moment of the motor. As we slide more to the right, we will see that the amount of the load that is being driven by the motor remains the same. It's because we ran a static analysis and we just have the static impact of this load being directly connected to the line. ETAP gives us the ability to create many types of plots. To do so, simply click on the motor starting plot icon, and as you can see, you can select in between all the devices that you have in your power system. In this case, I'm gonna choose bus 2 voltage as an example and create a plot for this event over bus 2 voltage level. You may now see throughout the 12 seconds of simulation time, we have the curve describing the voltage level at each moment of time of the occurrence of this event that we said earlier. But before analyzing this and before talking about this plot, let's make it more legible and more precise to have a better image. Simply click on each axis, like first the vertical axis, and change the setting in a way that is more suitable for you. Like in this case, we have the range for the vertical axis from 85% to 105%, which is a good range. The step between each number of percent that is going to be shown on the plot on the vertical axis, which I'm going to reduce it to 1. The minor ticks are okay, those little lines, and it tells us each second would be split into how many it will tell us each percentage. It's those little lines in between each percentage, which I'm gonna reduce it to 2 instead of 4. And also, in order to get a grid, I'm gonna put the minor grid for each minor tick. It's gonna put 1 line horizontally. You can also change the line attribute, like the color and the thickness, but we're gonna stick to the default setting and click on OK. Now you may see that we have the range of 85 to 105% of the nominal voltage selected for the vertical axis, and the steps in between these range are 1, which we have 85, 86 throughout 100 up until 105. And for the horizontal axis, the time axis, we can do the same thing. Change the process, change the steps to 1 and the tricks to 2, and also the minor grid, and click on OK. Now it gives us a better idea about what's the voltage level at each moment of time throughout the simulation. But as you can see, the curve itself, it's not legible, so we're gonna double click on that too and change the attribute for this line to red and the thickness to 3, and click on OK and OK. Now we can easily say that right in the 0 second, the voltage of bus 2 was at 99% of its nominal voltage level, and then right when we had the motor started, this voltage dropped down to 93.5, and for about a second we had this motor accelerating up until the second, which is running on its full load, and the voltage level now it's around 98.5. It's because the motor 1 is in line because of event 1. And as you can see again, the reason why you're seeing a flat line during the acceleration is because we're running the static analysis. One thing that I want to mention right now is about the acceleration time. When we do the static analysis, we can manually set the acceleration time of the motor by simply double clicking on its icon and switching to load tab. Underneath this window, on the bottom part of this window, we can see a field for acceleration time, static starting. It says from no load to full load, how long it takes. We're gonna change the full load to 4 seconds, for example, to see what would be the difference in the plot. This means that it takes 4 seconds for the motor to be fully loaded online. Now again, run the static motor starting, and let's make the same plot for bus 2. And now as you can see, it took 4 seconds this time for the motor to get to its steady state stage.